classification example, and we'll see how we can solve that using tensors in PyTorch. The goal of the tutorial is not to give you any lecture about classification, but how it works, the working structure in PyTorch, so that later on when we will be dealing with dataset, data loaders, and transformers, it will be much more easier for you guys to grasp the overall code structure and code workflow. Okay, so for any deep learning or machine learning model, likewise, it starts with data, then it goes for your data loading, getting the data, then pre-processing, then building of the model, tuning hyperparameters, then in training the model, testing with validation, dataset, inference, and finally deployment and saving of the model. Okay, so let's get started for this tutorial. Okay, it will be much more simpler stuff that we are going to build, and we don't have any dataset, so we'll take dataset from scikit-learn. Okay, let me see what happens with PyTorch classification. Will be requiring terminating all the other sessions. Okay, just give me 1 second, guys. Now it will work. So once our required modules we can load, then we will first load the dataset, and let me just give you a glimpse of the dataset. So here again we are loading torch for neural network purpose. We are loading NN module from torch, then for some basic plotting matplotlib, and just providing its a CPU version of 2.9.0 for PyTorch. Okay, now from scikit-learn dataset we are importing make circle function, and make circles takes number of samples, so we want 1000 samples. And the noise, okay, a little bit of noise for the dot, and a random seed, so that every time it will generate the same number of values. Okay, so now once it is done, let's just couple of x and y's. So my x data will look like this, and my y data will look like this. Okay, so as you can see, this is our x and this is our y. So x contains two features. Okay, well, this is feature number 1, this is feature number 2, and y is nothing but the corresponding levels for particular x. So let's first just convert this into one pandas data frame. So I'm just importing pandas pt.data frame, where let me call this one as x1, this one as x2. Okay, that's how your indexing works. This will represent I want all the rows, and this will indicate I want only the first feature to be x1, and the same for x2, and my level will be y. Okay, and let's just print the first 10 rows, x1, x2, and levels. By the way, I'm taking this example from Coursera, so if you guys have already watched it or have good understanding, because there is no meaning of creating newer coding exercise once it is already established, and it's a good coding workbook that I found for this example, so there is no need to create another one. Okay, now let's just check the differences, how many differences are there. So circles, that's our data frame dot level, that's this one dot value counts will give you the levels with corresponding counts with the pivot table. You can see we have 500 positive examples and 500 negative examples. Okay, now let's just visualize, okay, how these two classes will look like when we plot. Okay, so this is our x will contain the first feature, and y will contain the second feature, and we're just coloring it with the classification. So we can see it's a non-linear it is giving so it is correct, right? I think it's the ordering is wrong. Okay, x1, let's put 2, and I have x, and let's print the first two, and you can see it is mostly correct. So why it is not working, let's just see what's wrong with the assertion. Okay, it will give me some error, x1 and boolean value of tensor with more than one value is ambiguous. Let's just explain the error. Okay, I'm just taking some time. If you are already familiar with all of this, just cut this portion. Okay, Now let's move on with our code. We have x as our input. Let's just visualize the top 5 rows, and then we have y. Let's just visualize the top 5 rows of this one. So this will be our input tensor to the classification problem, and this will be our output. Okay, and this is the visual representation of the inputs along with their classification. Okay, now let's just move on. We'll just split the data into train and test using scikit-learn's test and split, like we used to do. sklearn.model selection. Previously from dataset we have imported the data, make circles. Okay, and sklearn.model selection, train test split, and inside train test split I'll call x and y as my tensors to be split, 20% test and 80% training data with a random seed. And let's have our data set's length to be displayed here. And first thing, now check what is the device on which all the models or tensors are stored. So here you can see it is not CUDA, I mean GPU is not enabled for this runtime. It's a CPU that we are using, so it's not a big deal. So first we'll construct one classification model. So let's just construct that model. I'm just picking up the code here. So again, this is the class, that custom class we are going to build for the model, and the custom class will take parameters in the very beginning, or attributes. The attributes will be nothing but the layer values, and in the forward class we have to, in the forward method basically, or for forward pass, we have to define the communication between these layers, right? So that's how you will define. So this super will enable this nn module calls, so that we can use all the features of the nn module that we are getting, we are passing through this circle model v0. That's the classification model we are building. So as you can see, we are defining the first layer, which is a linear layer, and in this linear layer the input will be 2, and we are writing one output will be 5 hidden layers, or 5 hidden nodes basically in the second layer. Okay, so our input size will be 2, as we have seen here. We have 2 input data, and our output will be of 5 nodes. Okay, and in the second layer our input will be 5, that will be exactly same of the output of the first layer, and our output feature, and we're just closing the basically network here, our output feature will be of 1. And once that is done, we are calling the second layer, and we are passing the value of first layer, and inside first layer we are passing the value of the input, and that's it. So what is happening here, the computation goes through layer 1 first, and then it is going to the layer 2. Okay, and once the whole class declaration is completed, we are just calling the class, we're just creating one instance, and we are storing the model details to the target device, that is CPU here. Okay, and let's just print the model. So you can see it's a linear combination of models, where the first layer has 2, 5 shape, and the second layer has 5, 1 shape. Okay, so the model creation is also done. Now the next one, it will be building the same model using sequential API basically. So here you can see it's similar to sequential API, whatever we have built here using this circle model version 0. So it is neural network.SQL sequential basically, and inside sequential we are passing the first layer, that is taking the input feature as 2 and output feature as 5, and in the second layer the input feature is 5, the output feature is 1, and again we're just printing the model, it is same model. And once that is done, let's just make prediction with the model. So we haven't done any training yet, right? For training you will be requiring one loss function and optimizer to be defined. So first let's just see what is the untrained prediction based on the random values assigned to the weights and biases. So length of prediction, the first thing we are going to print, then the second thing length of test samples, then first in predictions, and 10 levels that we are going to print. So as you can see, these are the predictions are nothing but some sigmoid function basically, and these are the levels of the corresponding test features. Okay, so till now I think you guys are sorted and everything is clear. Now next just move on. We have to figure out a loss and optimizer that I have been telling you for I think past 2 to 3 videos. So here you can see I'm using BC with logit losses. So it's a built-in sigmoid loss for binary classification, and the optimizer I'm using here is SGD with the parameters as models parameters and learning rate as 0.1. So let's just create this one, and then once this one is done, let's just create one function that will give us the accuracy, where first we are calculating the correct values, where how we are calculating the correct values is we are taking the true value of y and y predictions, and based on this two we are just comparing the similarity between these two, and if both are similar, okay, torch.equal will give me whether it is similar or not. Then based on that list we are just picking up the summation, okay, what is the summation of the value, and from that we are just picking up the item, okay. And once this correct will give me some scalar value, basically let's say it's 23 or 22, whatever. We are just divided with the length of the total values present in our level. That means mostly in our testing we have 200 samples, right, and we're just multiplying with 100, and that's our accuracy function that we have built, okay. So now to test, you can easily see what why logit is printing. So I have x test as my testing features, right, and let's just also send the tensor to the device and apply the model on top of it to get the prediction and print out the logit value. So this is my initial logit values without machine learning model training in PyTorch. And now let's just move on, okay. We are just going to use a sigmoid function on top of this logit, and let's just print the probabilities. So if you see, this is the logit value, and once you apply sigmoid function, then you will get the probability values, okay. Now once that is also done, what we are going to do, we are going to get the predictions from it. So my y prediction will be torch.round, and this probabilities are just going to make it round. So greater than 0.5 will be 1, less than 0.5 will be 0, and once that is done, we'll just trying to print, and then we'll check for equality, and we'll just get rid of the extra dimension that y predicts will give, okay. So I just print this one here, you'll see I have one extra dimension here, right. So this squeeze will just terminate this extra dimension. And now once these all things are done, right, let's just build the model, okay. So what we are doing, we have our train and test data set here, okay, just sending it to device so that every calculation or training the model and the data resides on the same device, okay. We are training it for 100 epoch or for 100 iteration. So for every epoch, for every iteration of the epoch, first what we are doing, we are making ensure that the model is in train phase, and once the model is in train phase, we are applying the forward pass using model and then passing the input parameter here, and then we're just squeezing out so that as we have just seen, right, this extra tensor got removed. And once that is done, let's use the torch.round function, and we apply the sigmoid function also, so that we can get the true predictions out of the values. And once we'll get the prediction, we'll just calculate the loss based on the loss function and accuracy based on the accuracy function. And once the loss and accuracy is getting calculated, let's apply the optimizer with zero gradient. First we'll make sure that all the learning from the gradient descent algorithm, all the small steps, that means your delta w and delta v will reset to 0. Then we'll initialize the backpropagation through loss dot backward, and then we apply the step encounter or step increment using optimizer dot step to update the weights, okay. And once that is done, our training will be completed, and once the training will completed, I will make sure that the model is in evaluation phase. So we'll just write this one model underscore 0.eval, and then with torch inference mode, that means we are now entering into the evaluation phase. Let's apply the forward pass in the testing data. I'll get some again logit values. We'll just apply the sigmoid on top of logit, and then we'll do a round to get the predictions for the testing value, then same loss and accuracy, and then finally for every 10 epoch, let's print it out, okay. So training and testing is completed, and that's how we'll create one. Now for printing of whatever learning happened, right. let's download some helper function for plotting. Okay, you can also copy paste the code for the helper function from here, and once the code is there, you just pick the plot, and you will see this is the train and test decision boundary prepared by your machine learning model that has two inputs and five hidden layers, and sorry, not five hidden layers, one hidden layer with five nodes, hidden neurons basically, and one output. And this is how your train test split looks like inside the model. Okay, so that's it for this video. In the next video we'll continue with this topic only, with different kind of models basically, so that you will have much clearer and better understanding before we jump into the actual complicated models, where we'll be using dataset, data loader, transformers, transforms mechanism of PyTorch, and we'll build some meaningful projects there. Thank you very much.